Please welcome Executive Vice President, Chief Strategy and Sustainability Officer at PTC, Catherine Kinneker, and Vice President of Sustainability at PTC, Dave Duncan.
Wow, I got my groupies. It's awesome. Maybe it's a rock concert, Dave. We showed up a little earlier. So great to get a chance to talk with all of you again this afternoon on one of my favorite topics, environmental sustainability. You know, it's no secret that we are at a critical moment in the world where we need to make significant changes to the way we live and how we produce products. You know, the problem probably doesn't need restating with this audience, but put very simply, we're destroying our wonderful planet. Now, from a materials perspective, we're using way more than the Earth's capacity, and waste is at an all-time high. You know, for those of us focused on the manufacturing sector, we know that 54% of global energy consumption is consumed by this sector alone. So it leaves huge room for improvement. Now, there is some good news because there is an incredible desire out there to solve this problem. Businesses and consumers alike want to buy cleaner products. Employees put sustainability as a top criterion when choosing which company to work for. And manufacturers are really showing that they believe that there's value to be driven by focusing on their environmental programs and their environmental initiatives. And they're focused really on three key areas. The first is dematerialization. That really means using better and less materials in the products that they build. And the second is energy efficiency, so using more efficient, energy-efficient methods in production, in logistics, in operations, and in service of the products that they make. And the third is that they're really focused on reducing waste. Again, reducing waste across production, across the servicing of the products, and actually, really importantly, reducing waste at the end of a product's life cycle. So, I am thrilled this afternoon to be joined here with Dave Duncan, our VP of Sustainability. Dave is our expert. He is driving our strategy here at PTC for both our internal initiatives and our customer-facing strategy around sustainability. And both of us hope that by the end of today's session, you'll be convinced of three things. First, that PTC is really committed to sustainability. Second, that we actually already have a portfolio of solutions across the entire product lifecycle that are delivering meaningful results, and we're investing in other areas. And last, but by no means least, that sustainability isn't just good for the planet, it's also good for business. So, Dave, let's dive in and start the conversation. Yesterday, we announced that we were committed to the science-based target initiative for both short and long-term reduction. Right. You want to share why that matters to everybody here?
Yeah, happy to. Let's dive into it. So what you see up here is the science-based target initiative chart for rapid decarbonization. And it may be familiar to some, but unfamiliar to others, so I'll take you through the high points. What you see on the top left is an initial inventory of our emissions that we have at PTC, which we've estimated fairly well. And the first thing that we need to do with this commitment is called the easier half, effectively. We need to remove about half of that emissions by 2030 using technologies and commercially practical ways that already exist today. We also commit to the long-term target, which is net zero, which takes down the second half. And about 10% is allowed for offsets on that second half, and some of that will involve some technologies that may not exist today or may not be commercially practical.
And SBTi will audit on a regular basis to keep everybody honest?
Yeah, that's right. So we have up to 2 years to have our whole plan verified. And then annually after that, they'll do a check-in with us to make sure that we're marching down that curve effectively.
And yesterday, we mentioned that it's really important. Our commitment is also really important for our customers. You want to explain why that's true?
Yeah, absolutely. So companies need to include some of their suppliers' sins in their carbon accounting. So for example, if we have a customer that, say, has ARR equal to 1% of PTC's revenues, they need to score 1% of PTC's emissions as part of what they call their Scope 3. And a lot of our customers are already committed on this trajectory. So now that we are, they can score us as, hey, PTC's proportion that we need to score will go down 1/2 by 2030 and then eliminate on the same slope that we're taking. So we're a supplier that they no longer have to worry about for carbon abatement.
Got it. How complicated would you say our measurement and reduction commitments are relative to those of our customers?
Yeah, well, we use the same accounting standards, which is the greenhouse gas protocol. We use the same reduction frameworks that the Science Based Targets initiative guides us on, as well as the same disclosures like CDP, soon to be CSRD in Europe. So that helps us walk in our customers' shoes because we're living through it, and then we can help our customers with the easier half, and we'll go through a lot of those examples today with technology that already exists, and also prepare for that harder half, which will require more thought and development. But yeah, it is easier for us at PTC to do this, or a little less complicated, because we don't manufacture physical goods. So we don't have a loading dock at our factories where we're taking on a bunch of embodied carbon from suppliers, and nor are we shipping a physical good that continues to use substantial energy that we would have to account for as well.
So for sure, like physical products have larger and more impactful footprints. Maybe, I think it would be really helpful, we have a chart on the next slide, to walk through what that looks like for our manufacturing customers and give people a sense of
Yep.
that.
Yeah, happy to. And it kind of from this morning's keynote, this would be our contribution to Liquid Networks. So if you're a sustainability expert, you would look at this chart and say, aha, that's a life cycle inventory with energy and material flows. Which is a type of diagram that they usually start with when they're doing life cycle analysis of products. But for most of us here, being digital industry experts, you can look at this and say, yeah, it makes sense to me too. We have buy parts coming from suppliers, we have make parts coming from material suppliers that come together in a factory, and it could go through tier 2, tier 1, ultimately OEM to operate and service, ultimately to end of life, and some circular opportunities to bring that material back. One point there is that in the factory, you may think that, oh, that's where all my emissions are as a manufacturer, but in reality, most of our manufacturers, it's on the sides, the upstream and the downstream, where 90% to 99% of the total emissions exist.
Yeah, it's the place where people see all the energy being used, but it's not actually where the true driver is. So with that framing in mind, I think it would be really helpful to walk through the product life cycle, and really from design all the way through to end of life. And we'll share some examples with you all of what's already been done, and maybe some promising areas for further focus as well. And I think any of you that were at the keynote yesterday, Jim mentioned that 80% of a product's footprint is determined by decisions made back up in the design phase. And so maybe explain that 80%, Dave, like where does that come from between upstream and
we
downstream?
hear about 65% to 85% are with design decisions, but overall it's pretty high. Because products are made out of materials, and embodied carbon is such a big piece of that, and for some energy intensive products, you have to make design decisions around how they use fuel or energy downstream as well.
Yeah, so, I mean, it sounds like sustainability is going to make the life of a design engineer a lot more challenging.
Yeah, absolutely, right? You used to try to balance performance and cost and maybe a little bit of time to market, but now you're adding footprint to the equation. So it rapidly becomes a plate of marbles that you're looking to balance in a multi-criteria sort of way. But the good news is, one, there's technology that can help there. And secondly, it's motivating for engineers to do this. Like, they all want to be able to reduce footprint and reduce cost in measurable ways in their jobs.
So definitely a challenge. Given the importance and the impact of choosing material supplier, yesterday we announced that we were expanding our partnership with ANSYS.
Right.
Let's give folks here a little more detail on what that integration looks like and why we're doing that.
Yeah, absolutely. So, materials front and center in design decisions, and has been for a while for performance, cost, and appearance, but what has really pushed it to the forefront, where designers need to get involved earlier in the design processes now because of all the embodied carbon and hazardous material regulations, recycling possibilities that are involved in that now, particularly as companies are making those commitments. So Granta offers a curated material database that comes with thousands of reference materials. Customers can add their own supplier-specific material variants on that, as well as their custom materials. So that it helps engineers find better material, and then ultimately better suppliers of that material, because suppliers also innovate in different ways to take footprint out of product. So let's take a quick look at this video. So as you see here, there's a user that starts in Creo, and then they punch out to the ANSYS Material Gateway database, which is purpose-built for a design engineer to use. And they select parts that the material engineers allow them to see based upon whatever criteria they want to, like density or footprint. And you see here a list of candidate materials returned. And they take a closer look at titanium, where they can see attributes across appearance, performance, footprint, other things. And they say, okay, great, that titanium is something that I want to use in this turbine part. So they select it to go in their project, and then they subsequently add that to the specific parts that they want to include that titanium in to include this turbine. So next, they go back out to Creo. And within Creo, now you can see that the Granta material ID is properly linked and part of the digital thread as a high quality reference on that Creo design. And this integration works similarly from Windchill as well.
Great. So Granta definitely helps with sustainability for these, I'll say, make parts. But what about pre-built components or buy parts?
Right. So there's been a strong market of supplier component databases for a while that both Arena and Windchill have integrated with. Some of these include Ascent, Compliance Maps, Silicon Expert, Octopart, which is now part of Altium, IHS Market. And the trigger for design engineers to get involved with this earlier were hazardous materials like reach and rose compliance. But more and more, these electronic suppliers are including embodied carbon in their data as well, so that helps with the footprint roll-ups and decisions that designers can make. And it's mostly electronics focused now with these catalogs, but now that embodied carbon is such a big deal, we expect this market to expand into other areas, and we'd be able to integrate in similar ways.
For sure. So with environmental impacts of mining and material processing, it's great to see that this is now like an integral part of the digital thread and digital transformation decisions. But it'll also drive other values like performance simulation and manufacturability planning. Speaking of manufacturing, yesterday we also announced that we had expanded our partnership with a priori. And this complements what we're doing with ANSYS really nicely. You want to take everybody through that?
Yeah, absolutely. So Granta does a good job of giving you your cradle to gate footprint that you get from your material as it gets to your shipping dock and your factory. And where a priori helps is in several ways. Not only estimating the footprint that would happen during the manufacturing, but also, is it manufacturable to begin with, and how much will it cost? So it helps you with those trade-offs. And the way it does that is it takes material definitions and geometry from CAD and PLM, and it runs a simulation with their digital factories and returns a scorecard that tells you how well you're doing, but more importantly, it prescribes ways for it to improve. So let's show you an example here. So in this scenario, a priori can run a batch job. It could be daily, it could be more frequent. That's based upon checked-in or state-changed parts within Windchill. And here you can see most of the parts come back okay, but there's one that has high risk. So here, the part owner in Windchill can look at this report and they can click on a hyperlink that takes them into the a priori AP design product, which is also purpose-built for a design engineer, and figure out, well, you know, why is the score high on this? And here it's because the inside diameter is too tight for quality milling, which can result in unwanted scrap rates. So it recommends here that a sounder quarter diameter be made. They go back into Creo, and reasonably quickly they can make a better inside angle that's a little more gradual on the inside there, so that their scrap rates will go down. And interactively, they can punch right back into AP design and rerun it. Said, okay, you asked me to fix this, I fixed it, how's it look? Great, the red's gone. So they fixed that problem. And subsequently, they can look at all the other data that they get back from that simulation to see if there's any other tweaks that they want to make to it. They can look at manufacturability, cost, footprint, and here they find a less severe, but a tweak that might be worthwhile in terms of, you know, potentially removing some material to get a smaller angle on the part, which makes it easier to manufacture and dematerializes a little bit, frankly. So there's a lot of value here for running this subroutine.
Definitely worth investing in. All right, so Granta, or ANSYS Granta and a priori both help with material selection, but reducing the amount of material is also another significant driver of sustainability. Yeah, it sure is. And let's show an example. Here's a 44-pound motor mount of a Volvo truck. It supports an 11-liter engine that weighs about 2,000 pounds. It's made out of iron. It functions really well, but I can barely lift this thing. It's a beast. I don't actually know what's wrong with you, Dave, because I can lift with one hand, no problem, the exact same part that takes even more peak stress than that old-fashioned mount that you have. It uses the same material, same casting process, and it's using our generative design technology. Want to explain a little more other than the fact that you need to go to the gym? Yeah. I mean, I could probably skip the gym and just hit that generate button a little bit more, because, I mean, here, what you did here is you removed between 50 and 60% of the embodied carbon of that part. But more importantly, you took 26 pounds out of the truck. Okay. That's going to drive down the road hundreds of thousands of miles. So that's going to reduce either fuel needs if it's diesel, or electric needs, or hydrogen needs if it's an alternative powertrain. For sure. And like, speaking of that, like, it's not that hard for design engineers to actually leverage these tools. And yesterday, for those of you that had a chance, Dave Genter ran a fantastic breakout session talking about what Cummins is doing with their Planet 2050 initiative. But maybe rather than listen to me, why don't I show you a quick video of what they're already doing in design and the kind of results that they're getting.
Designing for sustainability, it has many flavors to it. The place where I'm placing a lot of my emphasis is to make sure that when we design a product, we don't design it with any more material than is required to attain its strength or stiffness goals. So it's really looking at the full life cycle of the product and making sure you're not using any more material from cradle to grave. And to do that, you need special tools like Creo Generative, or things that help, tools that help you to understand where you are potentially putting wasteful material into the product. Some of the analysis tools within Creo enable us to do is to do the iterative work up front within design, where it's the most efficient place to do that type of work. Design engineering really does have a very, very important role to play when we're trying to meet our sustainability goals. We now know that when you apply these techniques, you can expect to save between 10 and 15% material use. And you can pretty easily understand or calculate what those benefits will be from a total CO2 perspective. But one thing really nobody knew until we did that work is how much that would translate to in terms of like overall cost savings over the course of the year. There was not only a big impact on the environment when you take that 10 to 15% savings and multiply that by the number of components that you make annually, but there's also a cost savings that comes with that too, and a weight savings, obviously. And the weight savings has compounding effects when that engine goes to work in a truck. So the less an engine weighs, the better fuel economy it gets. It really has a compounding effect. From a design engineering perspective, it really allowed our designers to go home at the end of the day saying that I saved $500,000 today, or I saved $200,000 today. And it really provided some value to their role that they had difficulty making tangible before we started this work.
Fantastic. I mean, there's a superb story. Not only is Cummins achieving their sustainability goals, they're also driving costs down and actually energized and motivated engineers in the process. So a triple win. Let's move on to the manufacturing side. We discussed several ways that engineers can set up the factory for success through materials and material supplier selection, lightweighting, and manufacturing simulation, but there's a lot more that can be done. One of the areas that there's a lot of folks out here talking about is energy management or energy efficiency.
Right.
Talk about some of the products that we're seeing and the partners that we're working with.
Yeah, so energy management, we mentioned earlier that the factory is the minority of emissions for manufacturers, but it's your scope 1 and scope 2. It's the direct energy that you can affect. So the Science Based Targets initiative and others prioritize bringing that down. So this is absolutely a priority for companies to do, and they're doing it. And energy management is really a derivative of ThingWorx digital performance management that finds hotspots, if you will. Like DPM classically does bottleneck analysis off of time loss, but through sensoring, energy management finds like literal hotspots in where too much energy is being consumed or water is being leaked or items like that. We've evaluated several ThingWorx-based partner solutions that are based on the DPM framework, and LTTS, Calypso, part of Rockwell, Transition Technologies, Connect.io all have proven solutions there, and they're seeing between 10 and 15% energy efficiency improvements when they deploy this. And the other area where it helps too is they get more precise about the product level footprint transparency that their customers are asking for from the factory. So energy management, that can be done independently in factories. The other area that we're seeing in manufacturing is a collaboration between manufacturing and engineering, which is manufacturing process management. CK, you want to tell us a little bit about Vestas?
Sure. Vestas, as you probably all saw, has showed up here in a big way at LiveWorx, but they have more than 150 gigawatts of wind turbines in over 80 countries around the world. And so they have by far installed more wind energy than any other company in the world. Now, some things that you might not know is for Vestas, each wind turbine is unique because it's unique for the location and it's unique for the wind pattern. And on top of that, the factory for Vestas is actually the operating location. So they are making extensive use of this, tying manufacturing process planning and modular design so that they can actually sustainably and with cost efficiency build these turbines. So by combining the modular design and process planning, they're able to provide the assemblers with up-to-date, configuration-specific, because I just mentioned everyone is unique, and visual work instructions so that the assemblers can assemble with high quality, even in the harshest, most remote locations. On top of that, they're leveraging IoT to actually verify that the assembly was done correctly, and then later in operations actually make sure that the ongoing service of the turbine, they get the information. Now, Vestas is not the only company in our customer base doing this. Another example is BMW.
Right, yeah. So Vestas does this, and Vestas generates clean electrons through wind generation, and BMW has this new I-Line series of EVs that are making a splash that can use those clean electrons to power cars as well. So similar to Vestas, where Vestas uses modular design as well as MPM for mass customization and distributed manufacturing, BMW does the same thing just for a mobile asset. So if you think of vehicles and how they mass produce them, they weigh about 5,000 pounds. So classically, if you look years ago, BMW would have built cars in Germany and then shipped them around the world, and maybe have different suppliers that contribute that are shipping into Germany towards that. But more and more with distributed manufacturing, they're able to regionalize their factories and portions of their supply chain, but with that comes added variances beyond just the product variances. You have different production lines with different equipment, some different local supply chains that are contributing, and you still need to produce a highly configurable vehicle with the quality that is given BMW such brand recognition, and they're able to use MPM for that and reduce a lot of shipping emissions as a result.
Great. Maybe we should move on to the next phase of the product life cycle, so the operate and service phase. And during this phase, there's really two big, large footprint items. The first is shipping or transmitting service workers or technicians to location to service the product, or shipping the product back to some central location. And the second large footprint activity is all that embodied carbon that's tied up in spare parts networks for the just-in-case stocking. And here we have lots of examples of companies really using our current service products and solutions to both get great business results as well as really do good for the environment. Maybe we should just talk about a couple. One, why don't I take the first one?
Sure.
Metso is a mining equipment provider. And before you all say something, mining equipment provider at a sustainability talk, the truth is there's going to be a spike in mining for renewable energy infrastructure over the next decade. And so working with our Servigistics team, Metso has been able to permanently drive out over 40 million of spare parts. So a lot of embodied carbon just completely eliminated. And business-wise, they've been able to improve their fill rates by over 3%. And because they have much better spare parts planning, you don't have any of that expedited shipping that happens when you have poor parts planning or errant parts identification. So really good story that's good for business and really good for the environment. Similarly, 3D systems from a field service perspective,
right.
Great results as well.
Yeah, so like our other customers that we talked about that are helping with the transition, 3D Systems is a leading additive manufacturing solutions provider. And the way they help move the needle is in a couple ways. One is 3D printers by nature dematerialize, because you don't have the same subtractive manufacturing constraints that you would otherwise have. But secondly, which many people don't know, is They also deploy 3D printers to remote sites. Think like a mining pad that's in a remote area or a large ship that's out at sea, so that they can print critical parts on the spot rather than have that asset down for a long time and spend all the fuel to helicopter parts in as an emergency. But 3D Systems has deployed through ServiceMax an asset-centric field service. And if you think of field service classically, it was more appointment-based. So if you think of cleaning services or your cable company, it's a foregone conclusion that you're going to roll a truck to the equipment or the customer site, and it was more of a problem of how do you efficiently move people. But with asset-centric field service, kind of like with Servigistics, you order a new part and manufacture a new part as a last resort, you send that dispatch as a last resort. Sure. There's so much that you can do remotely to resolve issues, either through software updates or helping the customer out remotely. And if you do have to roll a truck, you can prepare much better remotely, so you fix it in the first trip. So what 3D Systems has been able to do, and the results that they've seen have been astounding. I mean, 62% fewer parts used because they have precision diagnostics, and when their tech shows up, 39% lower chance that they're going to have to come back because they couldn't fix the issue the first time. And that second one has resulted in an NPS leap from 22 to 70. And if you're not familiar with Net Promoter Scores, anything over 50 is considered superb.
So I think this can tie to end-of-life recovery as well. They can drive parts and assets returns. And as we come to the end-of-life phase, product circularity becomes a critical need. Now, the reality is only 6% of the world is circular today, so we have a long ways to go. But there's a lot of both opportunities and challenges here in this end-of-life cycle. Maybe challenge and an opportunity? Yeah, so the opportunity is huge, because the idea is either when a part's end of life or an assembly or their entire asset, it's if you can reuse pieces of it and not have to send it back to the factory, or remanufacture it and not have to reprocess the material. Or if you do have to reprocess the material, go ahead, but at least you're not digging it out of the ground again. One, that's good for sustainability reasons, but more and more, that also makes commercial sense to do. And the technologies are largely there to be able to do that, like modular design. You know, with Vuforia, you can have disassembly instructions, but to date, it's mostly been commercial hurdles, because it's difficult for manufacturers to retain contact and relationship with whoever owns that asset as it gets near end of life. But that's changing rapidly because of one, a lot of the sustainability drivers that we talked earlier, but also regulations, such as in the European Union with digital product passport and the battery directive that's coming up. So manufacturers should view this as an opportunity. Like, they should welcome this, because service is such high margin, and this gives a really good reason to extend your business into service. Great. All right. I think maybe a round of applause for Dave sharing all these insights. Really fantastic. We know who the expert is here on the stage, but I hope during the conversation that we did a very quick tour around the product life cycle, and there's lots more examples that obviously we couldn't share in a half an hour. We highlighted that we spend a lot of time in design, because that's where 80% of the footprint is created by the decisions made there. And we talked about the new work that we're doing with ANSYS and a priori, that we're excited about what the future holds there. We also made the link between engineering and manufacturing, and by able to use these modular approaches with manufacturer process planning, you can really achieve some great results. And we showed you some really good for business and great for the environment stories in the operate and service part of the life cycle. And kind of highlighting the need that we've still a long ways to go on the circular element, so that we can really reuse, remanufacture, and recycle in that order, versus throwing stuff into landfills. I hope that through the conversation, the three things that I said at the beginning are very obvious to you. If they're not, we did something wrong. The first is that PTC is committed to sustainability, and we're really leaning in hard. We didn't talk to you about the Green at PTC almost volunteer army that we have. We have 30 ambassadors across the globe now, all leaning into activities around the globe that are really pushing this agenda forward, and super thank you to all of them. But we're leaning in both internally and externally. Hopefully we showed you that we already have products and solutions that help our customers throughout the life cycle, and we've more investment coming with our work with our 2 partners. And that sustainability is not just good for the planet, it is really good for business. And so, you know, we are super energized about this work and the work that we can do alongside our customers. And, you know, I'll leave you with one final thought, and kind of thought from the head and the heart. Let's not just imagine a better world, let's help create it together. Thank you, and have a great LiveWorx. Thank you, man.
Thanks.